Hello everyone, I'm Anushree Srinath and today I'll be talking about predictive analytics using Microsoft's Power BI. What is predictive analysis? Predictive analytics is a form of advanced analytics that uses both new and historical data to forecast activity, behavior, and trends. It involves applying statistical analysis techniques, analytical queries, and automated machine learning algorithms to data sets in order to create predictive models that place a numerical value or a score on the likelihood of a particular event happening. Predictive analytics software applications use variables that can be measured and analyzed to predict the likely behavior of individuals, machinery, or other entities. For example, an insurance company is likely to take into account potential driving safety variables such as age, gender, location, type of vehicle, and driving record when pricing and issuing auto insurance policies. Multiple variables are combined into a predictive model capable of assessing future probabilities with an acceptable level of reliability. The software relies heavily on advanced algorithms and methodologies such as logistic regression models, time series analysis, and decision trees. So what are these three types of methodologies that we discussed? Logistic regression is a statistical analysis method used to predict a data value based on prior observations of a dataset. The time series analysis is an illustration of data points at successive time intervals. Decision trees, on the other hand, is a graph that uses a branching method to illustrate every possible outcome of a decision. The data management process for analytics looks like this. The starting occurs with the requirement analysis, that is the business understanding, and understanding the use case underlying the business or the technology. Once this is done, the data has to be collected according to the requirements and suitable understanding needs to be made. Based on the data and the requirements that have been put forth, the data is prepared. This involves cleansing and also removing other unwanted features in the data and adding only those that the requirements specify. From this data, the predictive analytics models that we discussed before, that is logistic regression, time series, or decision trees, is used. This model is then evaluated for correctness against the testing data. Once it passes the test data and secures a good level of accuracy, it is deployed onto the target machines or the target environment. This also leads to business understanding as each evaluation helps the developer in understanding what more needs to be done for that technology. Where is predictive analysis used? One of the major applications of predictive analysis is in data and business analytics. Business analytics or business intelligence refers to applications and practices used to help businesses acquire a better understanding of their commercial context. The goal of BI is to help decision makers to easily view, analyze, and understand business information so that they are equipped to make informed decisions that best benefit the business. How is predictive analytics helpful for your business? It increases productivity, reduces cost, it involves fewer resources, it deploys faster results, it improves operations in quality and functionality, it helps in fraud detection, it helps in risk management, and it optimizes marketing campaigns. Let us go through each one and see what it means. Increase in productivity. Data that can be readily used for analysis allows beneficiaries to be more proactive and thrive in future predictions based on past data and not on traditional presumptions. Reduce in cost. Prediction helps acknowledge a not too late methodology, thus saving on the cost of a delayed processing that comes within an additional cost to it in most of the cases. Involving fewer resources. With the precision of the desired outcome, predictive analysis saves on any misallocated resources, further saving on both cost and time. Faster results. Capitalize on future trends with predictions based on new developments and customer acquisition models. Improved operations. This involves quality and functionality. Industries offering variable daily pricing like airlines and hospitality use this technology in their decision-making process, thus functioning more efficiently and also giving a good quality of results. Helping in fraud detection. With the increased cyber threats and criminal activities ruling over, methodologies relating to multiple layer analytics help recognize such frauds and eventually detect and prevent any sort of vulnerabilities. Risk management. Responding to challenges before they come can be done with the help of predictive analysis in real-time business. Optimizing market campaigns. Last but not the least, with the help of determining customer behavior, predictive modeling creates and retains profitable users from the marketplace. Thus, it is able to optimize the marketing strategies. The typical use case for a predictive analytics technology or methodology will be in detecting fraud, optimizing market campaigns, improving operations, and reducing risk. Detecting fraud will involve combining multiple analytics methods, and it can improve pattern detection and prevent criminal behavior. As cybersecurity becomes a growing concern, high-performance behavioral analytics examines all actions on a network in real time to spot abnormalities that may indicate fraud, zero-day vulnerabilities, and advanced persistent threats. Optimizing marketing campaigns. Like we discussed earlier, predictive analytics are used to determine customer responses or purchases as well as promote cross-sell opportunities. Predictive models help business attract, retain, and grow their most profitable customers. Improving operations. Many companies use predictive models to forecast inventory and manage resources. Airlines use predictive analytics to set ticket prices. Hotels try to predict the number of guests for any given night in order to maximize occupancy and increase their revenue. Predictive analytics enables organizations to function more efficiently. Reducing risk. Credit scores are used to assess a buyer's likelihood of default for purchases and are a well-known example of predictive analytics. A credit score is a number generated by a predictive model that incorporates all data relevant to a person's creditworthiness. That is, if a person has paid off his debts and loans on time, then he can be termed as a decent customer and can be given loans in the future. Other risk-related uses include insurance claims and collections. For this tutorial, we will be using Microsoft's Power BI. It is a business analytics tool and it is provided by Microsoft. It provides interactive visualizations with self-service business intelligence capabilities where end users can create reports and dashboards by themselves without having to depend on information technology staff or database administrators. Amongst the top contenders, Tableau and BI are head on head. We shall see why Power BI can be a better option when compared to Tableau. It is a recent build, that is a 2013 established build. The best use case falls under dashboards, whereas for Tableau it is ad hoc analysis. The best users for Power BI can be anyone, that is, any average person who does not know much about analytics can also go ahead and use Microsoft Power BI. It is very user friendly and easy to understand. However, Tableau is a little more tricky and requires some amount of expertise in data analysis and in the fields of business intelligence in order to understand. In terms of licensing, Power BI has rigid rules, whereas Tableau is more flexible. The investment required in Power BI is low since it has a free desktop version for Windows. Whereas for Tableau, it's a paid version and has a high investment required. For the overall functionality, Power BI and Tableau both fare reasonably good. In fact, Tableau has been rated to be a little better. However, when we compare other features, Power BI will be a more suitable option with respect to other features. Performance with large data sets, both of them are good and Tableau seems to be a bit better. Support level for Power BI is low, however for Tableau it is high. Infrastructure, it supports only SaaS, whereas in Tableau it supports any. And Power BI has a free desktop version for Windows, and Tableau has a free trial, however it needs to be purchased after that. Now let us move on to the installation. The Power BI website looks something like this, and the downloads can be officially done from here. The website in fact has small windows of tutorials going through what features are there, helping any user understand what it is. Once we click on the download button, which is there on the top or even at the bottom, we can start the download. This will lead to the App Store from which it can be downloaded. Once downloaded, we can begin the tutorial. The Power BI tool starts up and looks something like this. It involves support for many features and R is one among them as seen here. So we can get our data from here. There are many sources of data that we can use. It has a list of sources that we can tap into and use. So for today's predictive analysis, we will be seeing the cases of breast cancer. We will be checking for malignant cases. The dataset is easily available on R. So I have a script already ready here. The ML bench has the package ML bench has the breast cancer data and it can be loaded from here. Now to take support of R, we can go to File, Options, and in Options there is support for R scripting. Make sure that the Power BI tool is able to find the path where your R is installed. Once this is done, this will automatically detect, but in case you have multiple R installations, I have only one here, so it was easily able to detect. In case you have other more installations, then please choose whichever is your preferred R uh, installation. Once this is done, you're good to go. Now, for the data cleansing part, we can do it on R Studio. So what I've done here is I have sectioned it into after obtaining the breast cancer data from the ML Bench library. I have first converted all the values to numeric as that is required for the analysis. Um, And since we are checking if the case of malignant breast cancer, which is a type of feature for breast cancer, if if that feature is present in the data, then we are going to you put it as 1. Otherwise, we'll be assigning it as 0. And then I'm taking 70% of the data as training data and the remaining as test data. So this is the data preparation. So we can run this and we will be able to get the training and test data sets. I am exporting this training and training data set onto my local system, and that I can access from Power BI. So I can say get data and I have stored it as a CSV. So I will say text or CSV here and select it. So as you can see here, there is test and training data set that I have exported from the R codes. I'm going to select the training data since we are only going to check about the training here. So as you can see, this is the data set on the Power BI tool. The column names will be as column 1, 2, 3, so on. And we can rename the columns according to our wish in the scripting. And the delimiter is comma since it is a comma separated file. And there are roughly 200, to be precise 204 rows. So I will say load. It will apply the changes and load the data, and the data will appear here in the fields column. Yeah, so the training data, which is a data frame, has loaded on the R Studio. We can see that we have obtained the training data from here, and the same training data is available here on Power BI. Now, to involve scripting through R, there is an option here. It says R script visual, and a small console here will come up. It's an editor actually, which we can use to script and run the R files. So once I click on this R button, it says enable script visuals, and I will say enable. So as you can see, a field appears here, and you can drag anything from this visualizations to here and to this workspace and click on that workspace in order to use it. So for this workspace, for this tutorial, we'll be using R language and Power BI as the tool. Now for the data set, we just have to drag and drop these whichever columns we want onto either here, this editor, or here. I can drag and drop like this, or I can directly just go on clicking. So I want the first, second, third, fourth, all the columns. And as you can see, it is being simultaneously scripted here, so you don't have to explicitly write a code. It is directly doing that for you. Now I have all the columns. So if I just say plot the data set and run, as you can see, it's loading here. It's taking some time. It has loaded. This option here gives us a zoomed in feature. We can go back to the workspace. We can export this data and it will store as whatever we want. If we this is just for visualization purposes, where you can get a spotlight or a shadow behind as a 3D effect. If I remove this workspace will go. So coming back to this, I said plot dataset and that came. So since my script has the data set in the name of train data, I will be using the same thing, train data. So I can say train data is data set and plot train data and say run. It's working. It loaded the train data set. Now as you can see, there are other features also. This is just to hide. This is the settings which we already saw from file options and our scripting. So this is the same thing. Once we go here, this is the same thing. And this arrow actually goes to the external R ID, which is the R studio that we are using, and the script will come over here. Yeah. So as you can see, the script that we used in Power BI, the same thing has occurred over here. So I can code here and run it from here. So I will not be doing that, but I will be coding directly from here because we're focusing on Power BI. So once that is done, I have a small code ready. So what I'm doing is so this is what we already saw, this much we already saw, which is just I'm appending the data set to train data set, plotting the train data just to see if it is working. I'm renaming the columns, just like I said, just for our convenience. Instead of taking column 1 to 1 to 10, 1 to 11 as shown here, I'm going to be renaming it as thickness, cell size, cell shape, marginal adhesion, that is how what is the adhesive force between the two cells, that is the cell margins. And so all of those features are here. I'll be using two libraries, ML Bench and Caret. Now this for this predictive analysis, we'll be using logistic regression. So the logistic regression can be found in this GLM function. It supports even linear regression and other models. So I'm taking I'm taking the features of thickness, cell size, cell shape corresponding to class, which is at the end of this. Yeah, here. And the data is training data. So once that is done, I will be using the predict function and using this logistic model variable, that is the output of this logistic model on the training data. We can actually use this on the test data and check for correctness, but today we'll just be using the training data. And once we plot the predict variable, we'll be able to see how many of the cases, how many of the points in the data set have a what percentage malignant they are, and what percentage malignant breast cancer they have. So let's load this. Say copy and paste here. So it's the very same code. I'm just going to run it. So once I run that script, you can see that for the higher data points, that is between 100 to 204, this is the 204th point, the probability of having malignant breast cancer also increases. In the lower points, it is almost a 0%. This is points versus probability. So this is how we can do predictive analysis using R in Power BI. Thank you for watching.